Number of possible real roots of a polynomial by me, Ronald Tran. Today I'll show you how to find the number of possible real roots in a polynomial. First of all, here are some definitions and important key details that help you further understand the lesson. First of all, a polynomial is defined as an expression which is composed of variables, constants, and exponents that are combined using mathematical operations like subtraction, multiplication, and division, and addition. Here's an example. This expression can be used as an example of a polynomial, and the polynomial over here are the variable x and y, and the 7 is the constant, and then the 2 is the exponent. Furthermore, not really mentioned in the definition, these two are the coefficients, but sometimes you don't need them. That is what a polynomial is. Moving on, a root is a value that can be substituted for the variable that can be used as a solution. An example of this would be, say, 5 plus x equals 0. To solve this, we isolate the x, minus 5, and then we find out that the root is 5. And throughout algebra, we learn how to solve for the root, and that is basically what a root is. And finally, moving on, the fundamental theorem algebra. This is important for today's lesson because it is a sort of rule that states that every polynomial equation to the degree n with complex number coefficients has n number of roots in the complex number. And an example of this would be like x to n, or a demonstration of this is x to n. So x to the power n dot dot dot. We know that that equation now has n number of roots. Now everything has been explained, and we can continue on to show. I can continue how to find the number of possible real roots of a polynomial. Let me erase this. Here we have our expression a, our polynomial, x to the power of 5 plus b x to the power of 4 plus c x to the power of 3 plus d x to the power of 2 plus e x. So now that we know what the fundamental theorem of algebra is, we can understand that there's five number of roots. But then here's something I didn't explain. There are real roots and complex roots. In this, complex roots must be a conjugate pair. So that means, for example, there are five real roots, and let's call these real roots, and these are complex. And there are 0 complex roots. These are the total amount of roots. So then, if we have 4, let me continue on the thing, and there will be 1 complex root. But then we notice that, as I said before, there can only be complex conjugates that are pairs. So there's only 1, and that does not work. So 3, 2, but this one works. So then we know that it's possible for it to have 3 the amount of real roots and 2 real roots, since these are conjugate pairs. And then we can continue on 2 and 3. We know this is not possible because, as before, they need to be in conjugate pairs. And then we have 1, 4, And then we know this is possible likewise before, because there are conjugate pairs. And then there's 0 and 5, so there can be 5 complex numbers but 0. But then that's not possible because of the same rule. Their complex roots cannot equal 1, 3, 5, 1, 3, 5 slash non-paired numbers. So now that we know this and this, and this is why we can't have these amount of real roots. So now we know that there are 5, 3, and 1 numbers of possible real roots in this polynomial shown. So it would be 5, 3, and 1. These are the possible real roots of a polynomial. And that would be it for the lesson. Thank you so much for listening.